September of 2011, NASA proposes a new capability for human exploration, a massive rocket, the largest ever built, for a variety of missions beyond low Earth orbit. The new heavy lift capability will carry humans farther into space than ever before, making human exploration of the solar system a reality. The Space Launch System is born.
So the SLS is a national capability. Not only will it take humans further than we've ever been, it'll enable entirely new missions, scientific missions. It'll take you there faster, it can take more. If you've got multiple mission scenarios, you can bunch those up into a single flight, saving even more money.
The key tenets of the Space Launch System program are safety, affordability, and sustainability. We want to take our astronauts further than they've ever gone before and bring them home safely. We want to be affordable. We know we live in tough fiscal times and we have to live within our means. And we want to be sustainable. We want to have a program that is around for the next generation of children. We want to write the next chapter. We want to inspire.
NASA's SLS team started work immediately, using new methods of creating designs, conducting reviews, and even ways to improve scheduling and budget planning. The initial designs of the SLS show a powerful machine, a rocket capable of carrying 70 metric tons for human spaceflight, evolving to an even bigger rocket capable of launching 130 metric tons to space. The program begins with existing proven propulsion, using boosters much like the Space Shuttle program, but with even more thrust. The 5-segment booster has been tested 3 times, and work is underway on the flight-qualified booster, getting ready for its big test next year at ATK in Utah. The J2X upper stage engine is powering through testing at Stennis Space Center in Mississippi. These firings broke records and pushed this new engine to its limits. The venerable RS-25 engine, built by Pratt & Whitney Rocketdyne and used as the Space Shuttle main engines, will power the SLS core stage. The agency has 16 such engines in inventory, and new work is underway to update the flight computer. In order to feed these engines, NASA called on the expertise at the Boeing Company to build the SLS core stage at the Michoud Assembly Facility in New Orleans. Development welding is underway and new tooling is on order. Boeing delivered an important part of the infrastructure for the SLS earlier than expected when they turned over test bed equipment for the rocket's flight software.
Having the software test beds in the software development facility early helps us get a jump on designing our code, and we have to have hardware to develop code on. And it seems like the launch is a long time, way in the future, but 5 years is not very far away when you're designing code with this complexity.
While swift progress is being made on the initial configuration, the SLS Advanced Development Team is looking ahead to enhance and upgrade future designs of the heavy lift vehicle. The aim is to build a system that will be upgradable and used for decades, including the development of more powerful advanced boosters. Proposals have been selected to help promote SLS affordability, performance, and block upgrades. In the summer of 2012, the program reached a critical milestone with agency-level approval of the system requirements and system definition review. Guiding the course of the program, this milestone was a pivotal moment, allowing SLS to move from concept to design and target a preliminary design review for next year. With a basic design in place, the program started working closely with engineers at NASA's wind tunnels to test the aerodynamics of the rocket. Using the expansive facilities at both the Marshall Center and the Langley Research Center in Virginia, hundreds of wind tunnel tests using multiple configurations have been performed. As we bring the vehicle together, SLS works closely with the Orion program at NASA's Johnson Space Center in Texas and the Ground Systems Development and Operations program at NASA's Kennedy Space Center in Florida.
It actually takes all 3 to launch astronauts into space. You have to have the ground systems, the rocket, and the spacecraft. Today the teams are working together like a well-oiled machine.
The launch facilities at Kennedy include a mobile launcher and a brand new firing room for the SLS. The Orion spacecraft, also built at the Michoud Assembly Facility, is well into development. Kennedy is currently processing the test module for its first flight in 2014, just a few years before SLS takes its place on the launch pad. In the meantime, the Orion program continues improving the spacecraft, using water landing tests and parachute drop tests to expand their confidence in the design. When Orion flies for the first time, SLS will be flight testing hardware of its own, the Spacecraft and Payload Integration Adapter Ring. The engineers and world-class machinists at the Marshall Space Flight Center are building this section of the rocket using a one-of-a-kind milling tool. The finished adapter ring will mate the spacecraft to the Delta IV stand-in for the SLS during Orion's test flight in 2014, and to the rest of the Space Launch System in 2017. This adapter ring is being designed once for both applications as a part of NASA's commitment to affordable solutions for the human exploration of space.
What's important is that we meet the schedule to support the Orion test flight. We have several major milestones that we've already passed through. We've had 2 design reviews. So we're at a critical design review maturity level. So we're manufacturing the first units. And we're going to beat the schedule. We're going to deliver the hardware ahead of schedule. We're going to support the interface test, and we're going to be ready to fly come 2014.
We're moving forward with our eyes on deep space. And at the same time, we're humbled that we have the opportunity to write the next chapter of space exploration. We're looking forward to taking the next steps toward the future.
Each decision made in support of the Space Launch System has been carefully considered, contributing critical technology and functional knowledge to our nation's exploration objectives. NASA continues to expand our knowledge of the universe. The Space Launch System will leverage our successes from the past to help power the future for generations to come.